Hello all, welcome to my channel. Uh, I'm ready with a new video. In this video, we will discuss about dynamic partition pruning, which is an optimization that Spark does for certain types of joints to reduce the amount of scan that is happening on the larger side of the joint. So, uh, to start with, why we need this is so partition pruning, as we know, is something which is done by which is performed by many engines like Spark, Presto, all try to reduce the partitions that are there that Spark has to or Presto has to read. But these engines, like initially when Spark didn't have DPP, which is dynamic partition pruning, or Presto, these engines used to decide which partitions to read at the analysis phase, like not during the runtime, but at the analysis phase itself, whether we can filter certain partitions or not, and we can prune those partitions. But what Spark observed is that at many times that analysis that which partitions we should be reading should be done at runtime based on certain conditions rather than doing the analysis stage optimizations are good, but at times it might happen that the partitions that we are interested in might not be the partitions that we actually inferred at the analysis time because of some filter that was applied on one side of the join, which reduces the amount of partitions that we need to read. So this is looking at that challenge. Spark introduced this dynamic partition pruning, and this what it does is basically is when we are doing a join, and the join type is, let's say, a broadcast join. So in general, what happens in broadcast join is the smaller table is broadcasted to all the executors, and then whatever data is being read on the right side, whole data which is already read in the right side is compared, like which is compared to see whether there is a match or not. With this dynamic partition pruning, what it does it will push the filters which are applied on one side, and using that filter it will only read those partitions in the larger table, so it will not read the whole larger table uh, because there is some condition in the broadcasted table which allows this reading itself. So the join strategy remains same. The broadcast that was happening is as it is. Only thing that changes is uh, the amount of data that is being in the larger side of the join. So for example, if let's say we have an example where we are joining a fact table, which is a bigger table, to a dimension table on some certain column, and we are doing a filter on the dimension tables. Dimension table being smaller table, we are doing filtering on that. So even lesser amount of data will come in the right side of the join. So this is the right side is dimension, and that join is coming as something which is on the smaller side. So what dynamic partition filtering does it will say select everything, whatever we were trying to select, it will do that, but it will add a filter in the select part of the right side itself, means sorry, left side, which is the bigger fact table. So what will now happen is, let's say we wanted column 1 from the fact table that should be joined with the broadcast. So broadcast hash is already created, but while reading the table of the big fact, what it will do, it will say select column from the fact table, and then it will add a filter. So earlier this filter was not there, right? It was reading everything, created an executor, then this join column came, sorry, this it was joining on the values from the right side or the broadcast hash that has been created. Now it will do is, while reading the bigger table, it will read the bigger table with a filter which says where the partition column. So what it is it only read those partitions where the partitions values that are coming from the broadcast side are present. right? So let's say initially we had, let's say, take an example where we have a table which is joined, let's say order table is getting joined on, let's say customer table. Okay, customer table means customer is very less. The unique customers are less. The orders are very high because each customer is doing multiple orders. And let's say that order date is the order table is partitioned on date. Okay, and in the customer table, we have, let's say, the smaller table which has we had a filter on region, let's say. So what we are saying is, from the, let's say if the join was like this, that select something from orders join customers on order ID, customer ID is equal to customer dot customer ID, and we had a filter where customer dot region is equal to, let's say, US. So what will happen in there is that because the US region is filter out certain smaller number of customers, and while it will read the bigger table, which either it would have read all customers across, because the tables are partitioned on customer ID, now it can only read those partitions. So all the customers which were part of the US region only be loaded into the right side. So this is how the dynamic partition uh, pruning actually helps in reducing the amount of data that is being read in the larger table. So this the one example is that if, let's say, this was the join without any dynamic partition pruning. So see, the number of files read was 800, and number of partitions read was 100, and rows output was this, if we didn't have dynamic partition pruning in Elbow. But when we have enabled dynamic partition pruning, because it knows that, okay, I have to read only certain partitions. So you see, the number of partitions read, earlier it was 100, now it has changed, come down to 10, because only 10 values were returned by the broadcast filter, or the right side of the join, whatever table we were using, it had a filter. So that filter only resulted in 10 partitions being it only gave 10 partitions, and that's why when it was reading the left side of the table, it read only 10 partitions. And hence, because it read only 10 partitions, it only read 80 files. Earlier it was reading 800 files. Also, the number of rows, it was 22,000, now it can only read 1000 records. So this is how Spark dynamic partition pruning works, and it improves the runtime of the join that is happening. So when the DPP will be used, so there are certain things. One condition is dynamic partition pruning can be used when the smaller table, which is a smaller dimension table, has a filter that can determine the relevant partitions in the larger fact table. So if this condition is satisfied, and also there is a cost benefit analysis that, okay, whether doing this DPP will result in a faster query or it will induce a lesser cost in terms of CPU and IO. If while doing the planning, Spark will try to analyze that based on that cost. If this condition is satisfied and the cost is lower, then only it will choose a dynamic partition pruning. And what's the process of doing it? The process is the smaller dimension table is queried and filtered, and then a hash is built on that, and it is sent to the executors. Spark uses this result of this query and creates a broadcast variable and sends it to the executor. At runtime, Spark's physical plan is changed so that the dynamic filter is applied to the bigger fact table while reading the data. So that dynamic filter creates an internal subquery, as we saw here. This is the subquery we were talking, that it creates that subquery, and then uh, prunes the partitions that are required. By default, this is enabled since the Spark 3.0, but if we want to explicitly enable or disable, we can do it via this configuration, which is optimizers dynamic partition pruning dot enabled is equal to true. So this is how it will dynamic partition pruning works. And we can think of dynamic partition pruning as nothing but a predicate push down plus a broadcast as join. So that is easier or easier to understand in a sense, like uh, easier in a sense to find out what we have to do. For example, in this case, in this picture, if we say, so this is a broadcast, sorry, this is a, let's say, dimension, and the dimension has a filter, and the filter only selects, let's say, partitions of color green and sky blue. Um, and what will happen with this filter? This broadcasting will go, and in the right side, sorry, left side, the filter will be added. So see, we have multiple partitions. So we have also this partition, and there is a green partition. So if this filter was not added in this left side, we would have read everything here and then did a lookup. But with this filter, we will only read one and two, these two partitions, and then apply the filter. So this is something uh, visually how we can understand what will happen in case of a dynamic partition pruning is applied. Uh, so there are some conditions or constraint that we have to fulfill for that DPP to be applied. One is that the table that needs to be pruned, means the left side of the table, which is a bigger table, must be partitioned with any of the join key. Then only it will know, okay, this join, because I am joining on this join column, I can remove these filters. And the right side of the join has a selective predicate that can filter the join key. That means uh, when we are doing the in the left side, the broadcast that we are doing has a filter that can reduce the number of partitions that we have to do. So that's where this part comes, and it works with equijoins. There is it doesn't work as of now with non-equijoins. Reason for that is pretty in a sense it's an obvious that because if we don't know what all conditions that we have to fulfill, I mean there is no equality, it can be greater than, so we have to anyhow see all the partitions of that which are greater, or whatever condition we have, the operator precision operators intent wise. So that's why it is not applied to a non-equijoin, and it will not apply to an correlated query. It only works with the joins as of now. So this was it for what we understand what is dynamic pattern pruning and how it helps to reduce the uh, cost of a join operation in Spark. And to summarize, what happens is if we have a join where a smaller table has a filter which can return the partitions of the join key type, then what will happen? The first the broadcast will be so the smaller table will be filtered. A broadcast hash will be created out of that, sent to the executors. Executors will also have a filter based on the query that was in the right side of the filter, and that will apply to the partitions on the left side so that it can reduce the filters partitions. So that's it for the video. Hope you liked it. Have a nice day.